Okay, so today we talk about proportions and similar figures. Okay, we said in order for something to be a proportion, it must be a true proportion. What's a true proportion?
Where the measurements are it says the right thing.
Yes. Basically, they're equivalent fractions. They may look a little different, but it means that they're a true proportion. Basically, it means they're equivalent fractions is what that means. So when you have proportions in similar figures, what we've been doing so far is proportions in cost per hour versus cost per 100 hours. We've been doing that. Today we're looking at proportions in terms of what a shape looks like compared to another shape. So let's say, for example, that you have, let's start with triangles, because we all like triangles. So let's say I have a triangle that looks a little bit like this. We're going to go with right triangles to start. Let's say that this side is 240. This is triangle SAT. You like that? Ha.
I'm taking the ACT.
260 and 100. And this right triangle, which looks, is this an enlargement or a contraction here?
Contraction.
You got it.
That was expansion.
We have expansion and contraction. So we have two different triangles. And, yes?
Well, the numbers you wrote there, is that the distance between?
That's the length.
That's the length.
Yeah,
Length of
the
the
distance
side.
between S and T is 2.5.
Yes. What?
Does the 5 mean that? What does the 5 mean?
That's S. Triangle SAT.
The
What we're going to name first is we're going to name corresponding sides, meaning what side lines up with the other. One thing that you will notice, one thing that you'll notice about the two triangles themselves are they pointed the exact same direction?
No.
No. On right triangles, the first thing that I like to do, since these are right triangles, is I like to label them. In any right triangle, we have three different sides. Two sides are called the legs, and one side is the hypotenuse. So I like to label them myself before I really get started. This one's a leg. Okay, that means this guy's a leg. And this guy over here, the one that's directly across from your right angle, that's your hypotenuse. Okay, so this means it's sitting on these two. These are the legs. The legs make up the right angle. And the one across from the right angle, that's my hypotenuse. Now, what we're going to do first is we're going to talk about what side corresponds with the other side. Remember, whenever we label these, it is important to label it correctly. How do you label a line segment? What should it look like?
There's a line over
yeah.
Two letters with a line over the top, meaning that the line segment actually has a beginning and an end. It stops. Let's start first with our hypotenuse. Our hypotenuses are sides that correspond with one another. It basically means if you have this side, a hypotenuse over here, what's the other one? So if we name coordinating sides, the first pair that I would name are my hypotenuses. So this is AT, so I have to label it as line segment AT, and I'm going to say corresponds to, and my other side over here is called DH. And it has to have a line over the top. That way you are actually indicating that it is a line segment. Now, what about another corresponding side for this particular leg? Who can tell me what coordinates with ST? You are right. DI coordinates with that. Okay, and the last guy left is SA. So who is my coordinate on this side with SA? IH. What coordinating sides are coordinating sides are saying this side is to this side as this side is to this side. Now, the question becomes, how do we use that to figure out what proportions are and how to find an unknown? Glad you asked. Everybody got this much so far?
No.
Is that a yes? We're good?
No, also we're
part, the two triangles at least?
Yes.
Okay. I'll leave the coordinating sides for a minute. If you've already drawn the figures, then you're good. Then I'll draw the next two. Okay, coordinating sides do not always have to be two different figures. They can also be two figures that are encapsulated together. Tipping your chair before you bend it. Thank you. This would look a little bit like this particular triangle. And you will see this in your book whenever you get there tonight to your reading. It's on page 608. This is example 2 in the book. You may have two figures that are actually on the inside of each other. I have one interior triangle and one gigantic triangle. Everybody see how the difference
Oh,
between
they
the
look
two?
the exact same. It's just like a little smaller.
That's right.
Oh my god.
Coordinating
No.
figures. You like that? Coordinating figures just mean I have another shape that is exactly like the other one, except for I've either blown it up or squeezed it down. Either a contraction or a expansion. That's all we're talking about today. So let's label our points. This is D, this is B, A, C, and E. I'm going to start labeling some of the measurements themselves while you're getting that part down. Okay, now we've got a few unknowns, so go ahead and get that part down first, and then we're going to talk about how to find the unknowns.
Wait, is it like the ACB, the angle right there, and then A, like C, and A, those unknown?
CE is unknown, and DE is unknown. I have DB is 8,
Oh,
BA
yeah,
is 18, and AC is 22. So pretty much this triangle here in the middle, I've got all the measurements. I've got 3 different sides. This one on the outside, I've got the outside. I don't have this side, and I don't have this
So
side.
you're missing 2 legs.
You got it. I'm missing 2 of the
You're missing
different
a
sides.
leg and how about this?
It's not really a right triangle. This one's not right. It's not right.
It's wrong.
Okay, from proportions, what have we talked about before as far as units? What happens whenever you set up your fractions? If you have one fraction is equal to another fraction, what do we know about the units on the top? They're the same, right? So if I have cows here, I have to have cows here. If I have acres here, I have to have
Acres there.
Awesome. Same thing works whenever we talk about similar figures. It means we have to have coordinating sides on the top, coordinating sides on the bottom. So whenever we name those coordinate sides and the coordinate pairs, those come into play here. So let's talk first about what are our coordinating sides. Let's start over here on this side. Okay, the smaller triangle, what is the side of the smaller triangle on this one?
18. BA.
BA or AB, either one is fine. What is the outside of the larger triangle?
DA.
DA. Yes. Not just DB, because DB is only a piece. We're looking at the big one versus the little one. Okay, so these two are coordinating sides on the outside. I have the same kind of thing over here on the outside. I have the smaller side, which is A.
C.
So AC coordinates with A.
AE.
You got it. So this is a coordinate pair, or this is a corresponding side. These two are corresponding sides. Now I have one pair left. I have the guy that runs through the middle. So the first one is BC, BC to DE. You got it. When you list things in a triangle and you want to find one side versus the other, you have to list the corresponding sides in the same way that we've done them before. So if I list these two, I have both of the measurements, right? If I list these two, the coordinating sides both become the numerator. If I want to find the unknown, the two coordinating sides that I'm looking for become the denominator. Numerators have to be coordinating sides. So we might want to make a few notes at the top. I'm going to say two sides that coordinate. Become both numerators. And then two corresponding sides become the denominators.
Are those for the legs?
This one's not a right triangle, so it's just a regular old triangle.
I saw something.
Just, it's got 3 sides. That's all we have. Okay, now, just like in what we did last night, whenever we talk about our, let's say, cows per acre, whatever you have in your original sentence or in your original figure sides have to go on one, second figure sides have to go on the other. So let's talk about where we're going to start. This piece right here, what is this? AE is unknown and DE is unknown. Okay? How many unknowns can you solve for at one time?
1.
1. That's it. So what you first have to do is say, what do I know? And then find something that you only have one unknown in the corresponding pair. What is one side, one pair of sides that you already know both measurements? What are they? DA and BA. Okay, so we're going to start there. So we're going to start with each pair themselves. So I already know BA. BA is 18. So here's the first side. So I'm going to do the smaller figure here.
Does it matter though?
It doesn't matter as far as how you set it up, but you have to make sure that the smaller figure measures are your first fraction, larger figure measures are the other fraction. Now the fractions can swap, but you still have to have it set up the right way. So the larger figure will be the next one. So what is the corresponding side to the smaller figure? This is 18 and this little piece is 8. What is all the way from DA? 18 and 8 gives me, thank you, 26. So 18 is to 26 as, now we can find either one of the 2 unknowns at this point. So where do you want to start?
BC is D.
Okay, Franny says he wants to start with the diagonals. I know BC, but I don't know. Okay, is BC the bigger figure or the smaller? So I go to smaller figure, 24, and I do not know larger figure outside. So he becomes my unknown.
Variable.
Okay, so I have smaller figure, larger figure, corresponding sides, and corresponding sides. I promise it will get easier. We'll keep working. Okay, so now we use means extremes property, which means I have to cross multiply. So 18 times x is,
18x.
and 24 times 26 is
24.
624, is that what you said?
Yeah.
624. Okay, now, I have a number or coefficient touching a variable, which means we have what function? How do I get rid of multiplication? Divide. So divide both sides by 18, and what do you get?
34, 26. So 34 2/3.
34 and 2/3, is that what we have?
Because it goes like 26.
Yeah, you're right. It's 34 and 6 repeating, which is 34 and 2/3, one of those fractions we should know. So what does that mean? Who is this? Okay, that is x, but it is DE. That's DE. So this becomes 34 and 2/3. Now, I only have one piece that I don't know, and guess what I can still do? Do I know both of these in the smaller figure?
Yeah.
Can I leave them alone? Yeah. If I know those, I can use that same fraction pair to compare to the larger figure every time. So if you know one corresponding side, you can use that every time. So now, what's another side that we do not know?
CE.
We do not know CE. Oops, sorry. Probably should have written that. We do not know CE. So let's start with CE. C, we actually want AE, because that's the larger figure, right? He's the larger triangle. AC, on my bigger one, is what?
X.
22.
I can't see it.
Is 22. And on my outside it is, do I know what AE is?
No.
No. So, sorry, I'll write this back. Smaller figure, larger, whoops. You guys didn't stop me at all there. We're going to start over. Sorry, Bronny. Alright, I'm going to use the first pair that I have, so I'm going to compare AB, which is 18, to 26. So remember, same sides, same coordinating pair have to be on the top. This is where we just messed up. Now I'm going to compare the bottom. Smaller figure is 22 is to unknown. So now what do I have here?
Question.
Means extremes. So 18x. That looks strange.
Why 26? Is it 18 plus 8?
18 plus 8 is 26. So 18 is to 26 as 22 is to
X.
x. So here we go again.
X is equal to 31.
18x is equal to 26 times 22 gives me 572.
Yeah.
And we divide everybody by 18 and we get,
31 and 7 repeating. I don't know what that is.
it's going to be bizarre, but that's all right. There are going to be some that are going to look strange. You're going to start with whole numbers, and then you're going to go to the next one and go, that does not make any sense. You're going to get some yucky decimals. It's going to happen, and it's totally okay. Expect that. Tonight, what I want you to do is this. Tonight, I want you to read section 9.9. Now, did we learn our lesson the last time that I asked us to read?
Yes.
Read 9.9. I want you to look at, this is pages 601 through 604. I want you to look at the examples and solve at least one example from the book. That's all you have to do tonight. One example from the book, you only have to solve one. So make sure you read. Make sure you know the terms. What are corresponding sides? What does that mean?